Hello everyone. Today we're going to be looking at the integrals of natural exponential functions. Recall that differential of an exponential is the exponential itself, and if you have a differential of e to the power u where u is further function of x, then e to the power u du by dx. So these differentiation rules helps us to find the integral rules. So the integral of e to the power x dx is in e to the power x plus c. And the integral of e to the power u du is e to the power u plus c. So it's pretty simple. And let's look at the indefinite integrals first. Now, notice you have e to the power 2x. What we know is that if we have e to the power u du, it will be e to the power u plus c, but this u, guys, remember, is this is where you are going to use the u substitution. Okay, so here's because you're not having the normal e to the power x dx, so you're going to say, hey, let u be 2x. Okay, so this du now becomes 2 dx, or du over 2 is dx. Now go ahead and make the change to the original problem. So the e to the power 2x dx is now e to the power u times du over 2. So you're able to get into this scenario where e to the power u is same as you're doing, remember, e to the power x dx. Okay, so this one is half e to the power u. Remember, write u back in terms of the x's. So it's half e to the power 2x plus c. Okay, so in a nutshell, whenever you're given a problem, it's very important to keep this in mind. Exponential integrals are the exponential itself. If you do not see that, if you see something of your coefficient of x to be different than 1 or power to be different than 1, basically it simply says do u substitution. So let's look at the second problem. Integral of x squared e to the power x cubed dx. Notice that the differential of x cubed is x squared. Okay, so you can say, hey, u is x cubed. So du is 3x squared dx. Every time you see a scenario where you don't see the normal integrals, and always think in terms of u substitution first. Then here du is over 3 is x squared dx. So the original problem, x squared dx, is now going to be du over 3. Okay, so this integral now can be written in terms of u as e to the power u times du over 3. Now, integral of e to the power u is simply an e to the power u. So it's e to the power u over 3. Now remember, the original problem was in x's, so you have to change the u in x cubed. So your final answer is e to the power x cubed over 3 plus, remember, c at the very end. Now let's look at this problem. E to the power x sine e to the power x dx. Now we all know that the integral of sine x dx is what? Negative cosine x, right? I'm sorry, it's not nicely written. Okay, keep this in mind. Integral of sine x dx is minus cosine x. Okay. Now you have a scenario where it is different than x here. So put that as a u. So u equal to e to the power x. So what is du? E to the power x dx. So now our function, which was this integral which was given, becomes sine u du. Now integral of sine x, which is simply integral of sine u, is minus cosine u plus c, but remember in the final you have to change your u to the x. Minus cosine e to the power x plus c. Okay, let's look at some other problems. Now clearly, we have an exponentials and we have rational functions. So whenever in doubt, let's see if an exponential function can, the u substitution can help. So this is a problem where it is like u prime over u. So we have to first figure out what is the right u. So if I take the differential of u here, I will be able to get rid of the ex on the numerator. So u is 5 plus e to the power x. What is du? E to the power x dx. Wow! So this problem now becomes what? Du over u. Now remember, the integral of du over u is what? Natural log of absolute value of u. But your final answer has to be in the variable x. It's natural log of 5 plus e to the power x. And remember, it's an indefinite integral. In the very end, make sure you write down a c. Okay, in the next problem, notice, even if I take ex to be u, I will not be able to take the differential and be able to get rid of the numerator. So in this scenario, another strategy has to be taken place. And that strategy is that if you have only one term in the denominator and many terms in the numerator, go ahead and separate each of these numerator terms. So I can write this one as now e to the power 2x over e to the power x plus 5 e to the power x over e to the power x minus 8 e to the power x. Now, simply do your exponential rules. So, this is e to the power 2x minus x, simply x. This e to the power x cancels, plus 5 minus 8 e to the power minus x dx. Now, this whole integral is e to the power x dx plus integral 5 dx minus 8 e to the power minus x dx. The first two are very simple. Oops, it always messes up. Trying to get some space, guys. So this is e to the power x plus 5x. Now to do this problem, we will have to do u substitution because it is not the normal e to the power x. You can say, hey, u is minus x, du is minus dx. So, e to the power minus x dx is now minus e to the power u du, which is minus e to the power u. Or, when you change, it is minus e to the power minus x. So when you plug this one back here, you get minus 8 times minus e to the power minus x. Final answer, e to the power x plus 5x plus 8 e to the power minus x plus c. Okay, let's look at other set of problems where we have some trigonometric functions. Now, in the first one, you see integral of e to the power tangent x secant square x. Now, we all know differential of tangent is secant. So, that gives us the idea, use u to be tangent x. Du is what? Secant square x dx. So, the problem now becomes e to the power u du. Final answer is e to the power u, change u to tangent x, plus c. Okay. Over here, you have two terms in the numerator and denominator. So, the first option is, let's do u substitution. If it works, perfect. So, you're going to say, if I take the differential of the denominator, I am going to get the numerator. Let's look at that. U is e to the power x minus e to the power minus x. What is du? e to the power x minus of e to the power minus x differential of minus x dx, which gives us e to the power x plus e to the power minus x dx. So when I make the changes, what do we see? The top is nothing but du. The numerator is a u. An integral of du over u is a natural log of absolute value of u. And we just have to go and make the changes. Natural log of e to the power x minus e to the power minus x plus c. Now remember, these were indefinite integrals. Now let's do some definite integrals. Okay, now e to the power minus 2x. So as usual, we're going to do the u substitution. U is minus 2x and du is minus 2 dx, or du over minus 2 is dx. Now that takes care of the integrand part. Let's look at the limits. Remember, this is x equal to 0 and this one x equals 1. So what do we see? When x equals 1. Now what is u? When x equals first 0, u is also minus 2 of 0 is 0. When x equals 1, u is minus 2 times 1 minus 2. So this problem now is now equal to 0 to 2 e to the power u times du over negative 2. Or negative half out, 0 to 2 e to the power u du. Remember, we're going to again apply the first fundamental theorem of calculus, which is e to the power u integral, that indefinite, and then write down the limit of integrals, integration here. So you have half with a negative here, e to the power square minus e to the power 0. We all know e to the power 0 is 1, so it's minus half e to the square minus 1, and that's it. Let's do another example of definite integrals. Okay, we all know that the integral of sine is cosine. So in this problem, from definite from 0 to pi, I have e to the power sine pi x cosine pi x. I'm going to start with my u. I'm going to say, hey, u is sine of pi x. What's du? Cosine pi x differential of pi x times dx, which is pi times cosine pi x dx, or du over pi is cosine pi x dx. Now we got to go and do the math here for the limits. Now when my x is 0, u is what? Sine of 0, which is a 0, because pi times 0 is a 0. When x is pi halves, what is u? Sine of pi times pi half, which is sine of pi square over 2. Okay, you can't do anything. The sine of pi square over 2, guys, is going to be just a number. Okay, don't make the mistake of saying sine of pi square over 2 is 1. No, it's not. So when you make the changes here, you're going to go from 0 to pi square, okay, over 2. And e to the power u over pi du. So 1 over pi, 0 pi square over 2 e to the power u du. Now apply the first fundamental theorem of calculus. It is e to the power u 0 pi square half, or 1 over pi e to the power pi square over 2 minus e to the power 0. Final answer, 1 over pi e to the power pi square over 2 and minus 1. Okay, now let's look at some differential equations. We would like to solve this differential equation, f double prime equals half of ex plus e to the power minus x and then find a particular solution which will satisfy these given conditions. Now remember, when you solve a differential equation, it means find y, which is f of x. That's what it means. And in other words, to take the differential off, you take integrals. So f double prime of x is d square over dx square of f half e to the power x plus e to the power minus x. So we integrate first. So when we integrate, it's d dx of d dx. That's what it means. This one is this, of f of x, equals integral of half e to the power x plus e to the power minus x dx. And we have done this one before. Now remember, the integral and the differential cancel out, and we're now left with d dx of f of x. And we take the integral of this one as half e to the power x minus e to the power minus x over 2 plus c. If you forget it, you can go back and see how I have done this one. Remember that e to the power minus x dx is minus e to the power minus x. Okay, now remember, we are going to find, this is the general, it's not the solution, right? You have to find c. It says f of 0 is 1. So this is what f prime of 0. Remember, this one is f prime of 0. So 0 equals half e to the power 0 minus e to the power 0, minus with the still 0, plus c. So 0 equals half of 0 minus this is basically 0. So c is a 0. So what do we see? That df over dx equals half e to the power x minus half e to the power minus x. Now remember, you have to solve for f of x here. So take the integrals again, integrate. And what do we get here? Integral of d dx of f of x is integral of e to the power x over 2 minus half e to the power minus x dx. Okay, let's do the math here. So remember, the integrals and the differentials cancel out. So we get f of x equals integral of e to the power x over 2 minus half e to the power minus x over 2, or I can write half out e to the power x minus e to the power minus x dx. So this is half of e to the power x minus of e to the power minus x, remember here, plus c, and this is f of x. So f of x is now half e to the power x plus e to the power minus x plus c. Now we're going to apply this condition that f of 0 equals 1. So 1 equals half e to the power 0 plus e to the power minus 0, basically just still 1, So which is basically half of 1 plus 1 is 2. Remember, this is 1 plus c, or 1 equals 1 plus c, or c is 0. So the final answer, guys, is, f of x equals, remember the c is 0, half of e to the power x plus e to the power minus x. Okay, so we have done these problems, all variety of these problems, and now it's your time to do practice problems. So you have the problems on slide number 22, 20, 21, and 22. Thank you.